We have learned some ancient wisdom about prime numbers, and today we are going to learn a really cool idea which is called prime factorization. And this will lead us to a very important theorem which is called the fundamental theorem of arithmetic. But let's start out simple and talk about prime factorization. So, what is prime factorization? Well, prime factorization is really writing a number as a product of its prime factors. So, what do I mean by that? What I mean by that is let's think about a number like maybe 18. Okay, so 18, we know it's not a prime number because we can write it as a product of multiple kinds of factors. It has more factors, like you can write it as 1 times 18, 2 times 9, 3 times 6, so on and so forth. But if we start to divide 18 by prime numbers, we find that the smallest prime number that is divisible by is 2, and 18 divided by 2 is 9, right? Which really means 18 is equal to 2 nines. That's what I really mean, right? Okay. And now let's think about 9. So 9 is divisible by 3. It turns out to be 3. What it really means is that 9 is equal to 3 times 3, right? And similarly, so now we're done because now we can write, so this would be the prime factorization of 18. The prime factorization of 18 is that we're going to write it as a product of factors, each one of which is prime, right? So please note that this is really, so this was 2 times 9. So this was really the 9. So this was 2 times 9. And 9 was written as 3 times 3. So it is 2 into 3 into 3. It becomes, so we can compactly write it in index notation as 2 into 3 squared. Okay. So that's called the prime factorization. Now, as I said earlier, that prime factors play a very important role in all of modern finance, and prime factorization is really the key thing that gets involved when you're trying to deal with financially secure sites. So that's a very important thing that the algorithms for prime factorization are very important in modern day finance. In any case, so now what we want to do is, so this is called prime factorization. Let's try another one. Let's try a number like 24. So here's another attempt at a number like 24. So I can write 24 as 2 times 12, and I can write 12 as 2 times 6, and I can write 6 as 2 times 3. So the prime factorization of 24 is 2 cubed into 3. Okay? So you're always dividing by the smallest possible prime and seeing how far can you go, and then you end up with a factorization which is called the prime factorization. Okay, so now let's try to organize this computation in a bit more efficient way. Similar to like what we did in long addition or long multiplication or long division, these are very efficient algorithms. So let's try to come up with a nice efficient algorithm for doing prime factorization. And this is fairly straightforward. So let me try to show you how to do prime factorization. So here's 18, and I want to figure out prime factors of 18. But I know 2 nines are 18, or another way of saying it is that 2 divides 18. So it's 2 nines. And then I have 9. 9 does not divide 2. So remember, we have to go up the prime ladder. So 2 is a prime, 3 is a prime, 5 is a prime, 7 is a prime, 11 is a prime, so on and so forth. So we continue trying to divide the number by the smallest possible prime. So 9 does not divide 2, but 9 does divide by 3. So 3 threes are 9, and then 3 certainly does divide 3. So the prime factorization So our prime factorization of 18 is 2 into 3 squared, just as earlier. So let's try something new, like maybe 60. So here's 60, it's a big number. Let's try uh, finding the prime factorization of 60. So 60 is divisible by 2. Why? Because the last digit of 60 is 0, and we know the rule of divisibility rule, which says that if you end with a 0, 2, 4, 6, 8, then the number is going to divide by 2. So then 2 times 30 is 60. And then 30 is still an even number, so it divides 2. 2 times 15 is 30. And then 15 does not divide by 2, but it certainly does divide by 3. 3 fives are 15, and 5 itself is a prime number, so it only divides by 5. So the prime factorization of 60 is 2 squared into 3 into 5. So this is how you can very easily calculate prime factors. Now, what I would suggest for you to do is that you try a few questions on your own with the help of your teacher. And then I want you to mull over a question. So after you have done a few prime factorizations, I want you to mull over this question. So here's the question. The question is that I'm going to tell you 2021 is a number. It's not a prime number. Why is it not a prime number? Because I'm telling you it can be written as 43 times 47. Now, please note that we already know remember, we had our famous sieve of Eratosthenes. So Mr. Eratosthenes has already told us that 43 is a prime and 47 is a prime. So these are both primes. Okay? So we know that 2021 is equal to 43 times 47, and 43 and 47 are both primes. Now the question is, and are there other prime factorizations? So this is a big question that you want to think about. Are there other prime factorizations? So this is what I'm asking you to mull over. And can you write 2021 as a product of two other primes? So let me try to help you with the question. Think about a number like 18. Well, if you look at the prime factorization of 18, this is essentially the only way you can write it. Okay, you can try at home. You will not find a different way of writing it as a product of prime numbers. So it's unique up to the ordering. Like you can write it as 3 times 2 times 3 or 3 times 3 times 2. But 2, 1, 2, and 2 threes will appear in the prime factorization of 18. So the same thing applies to maybe 60, which we wrote as maybe 2 squared into 3 into 5. And it's also unique up to like the ordering, which means you can write it in a different order, but 3 2s, 1 3, and 1 5 will appear in the prime factorization of 60. So are there other prime factorizations? In this case, for 18 and 60, you are clear there are no other prime factorization. So the answer is a big no. There is no other prime factorization of 18 and 60. But is there another prime factorization of 2021? And uh, if we weren't focused on prime factorizations, then clearly, for example, even a number like 18 has multiple factorizations, but we are talking about prime factorizations, right? You can write 18 as a product of two different factors. But here we're talking about whether prime factorization is unique or not. It's a deep question. Hope you enjoy thinking about it, and I'll see you next time.